Hello, I am, sorry about that, Dr. Wagner, Andy Wagner, OBGYN and genetics. Very nice to meet you. Thank you so much for attending this morning. Unfortunately, I didn't know I was going to have a conflict when I originally signed up to be a part of this discovery series. But after talking with Dr. McKnight, said I'd be able to do a recording of this. So hopefully this works out okay. I'm recording on Zoom and uploading to YouTube and for you to see. I'm going to tell you a little bit about my kind of small angle within OBGYN genetics. So we'll do a little journey of what I've done, how I got into it, what we do within our department, what my clinical interests have been, do a little exercise, and then do a little singing. So a little bit about me. Where did all this OBGYN and genetics start? Well, my dad, who, oh, you can't see my mouse. Let me change it to the laser pointer feature. My dad here was a resident in OBGYN at Northwestern, finished back in 1978. I was about 4.5 years old at this time. And so growing up with a doctor in the family, I'd say definitely gave me some interest in medicine and this hereditary predisposition to go into medicine. In the summer between freshman and sophomore year of college, I was at the University of Wisconsin. I grew up in Milwaukee. I did a summer job with this geneticist, Dr. Rafael Alahalde. He ran a lab that did chromosome analysis, blood testing, prenatal ultrasound, and gave me some interest in this. Essentially an internship because I realized at the end of the summer I wasn't getting paid, but I did get a lot of experience with this. And this was even before I took a formal biology course in college. Then starting the next summer, I worked for 3 years within the Department of OBGYN at the University of Wisconsin. I was a research assistant, but I also was like the IT person. I made a lot of copies. I helped out with various research projects, some of which was going through medical charts and compiling a lot of data. I helped out with sheep research. They eventually gave me a couple of projects of my own where I looked at women with diabetes in pregnancy and was any of their screening to see if there was a higher chance for chromosome problems in the pregnancy or problems with the development of the spine, which is the same thing I am still doing today. They let me do this project, which actually was part of a class. And then through that interest, it helped me with this paper that I wrote for a class that eventually got published with my dad. I need a little help and help to have somebody with an MD behind it. And basically, this is an ethics talk on the same things that I am doing nowadays. So then I stayed at the University of Wisconsin for medical school. I still had that idea, maybe I was going to go into prenatal genetics, OBGYN, high-risk obstetrics. Even though kept an open mind as to what I wanted to go into. By about Thanksgiving of my 3rd year of medical school, I knew I wanted to do OBGYN, but still had an interest in genetics. I did a rotation near the University of Wisconsin Hospital in pediatric genetics, but then did my OBGYN residency training in Milwaukee at Aurora Sinai Medical Center. And about by my 2nd year of residency, knew that my interest in what I'll explain a little bit later, prenatal diagnosis, looking at pregnancies on ultrasound, trying to figure out when there were certain problems seen on ultrasound, what were the causes, what could be potentially done about that, what might this mean for them in a later pregnancy, what might this mean for other family members. And I realized I could do that through genetics. So I spent a month at the Detroit Medical Center, what year was that? 2002, to learn more about that. And that helped me get into what's called a fellowship, which is training after residency. So OBGYN, so college is 4 years, medical school is 4 years. OBGYN residency is 4 years. Then I did a 2-year medical genetics residency or fellowship, which is training after completing residency at McGee Women's Hospital at the University of Pittsburgh, which is where I learned to do all the things that I'm doing nowadays, doing genetic counseling, speaking with patients about what these potential issues for their pregnancies might mean, preparing for pregnancies, and the other part of my job related to family or personal histories of cancer. After those 2 years, I moved on to the University of Oklahoma in Oklahoma City for 11 years and joined the faculty at Northwestern in September of 2016. It's been great here, kind of coming full circle to where I lived between the ages of 9 months of age and 4.5. So I was saying my job kind of consists of 3 different things. Prenatal genetics is the main part of it. And basically what I knew about genetics going into it from my time in college and in residency. So genetics and OBGYN have been linked together for many, many years. And I think that's been always great awareness of what family histories, personal histories, what's going on in previous pregnancies, how that may impact lifelong health care, the current pregnancy they're having, other family members, what that might mean for them in building a family. So for many years, we've had this group of questions that when somebody's coming in for their first prenatal visit, we ask them these various questions, like if they're going to be 35 or older at the time of delivery, do they have any family history of these particular medical problems? Is there any family history of Down syndrome, which is a chromosome problem where there's an extra chromosome number 21? Is there a history of these medical problems? Are they taking any medications in pregnancy that potentially could cause problems with the pregnancy? And basically, if you check off yes on one or more of these, that means you should have a genetic counseling appointment. I work with the 2 offices I'm at, 21 fantastic genetic counselors. And what is a genetic counselor? They have a master's degree in genetics on how to explain the various testing options that we have, how medical problems could be passed on through a family with what are called the different modes of inheritance, which you probably have learned about in various biology and science courses like autosomal dominant, autosomal recessive, X-linked recessive, how to make these very difficult to understand concepts understandable, guiding people through the process, helping families make sure they know if they're doing particular testing, whether it's blood work on them or on one of their children, or testing a pregnancy. What does this mean for them, for their family? What are all these implications? And they do an amazing job of talking men, women, children through the entire process. And I'm very fortunate to work with such great genetic counselors. So we do various types of screens and tests in a pregnancy to help give information. This is the whole idea behind everything we do. We have screens which say what are somebody's chances of having a baby with a particular problem. And these can be through blood work or a combination of blood work and ultrasound, or just ultrasound. There are tests. So screens say what are somebody's chances of having a pregnancy to have a particular problem. These diagnostic tests will say 100% yes or no, will the pregnancy have an extra chromosome? Will have the appropriate number of chromosomes? Will there be a gene mutation because we're seeing something on ultrasound, or because there's a family history of something and there's a higher chance for that pregnancy? And there are tests done in the 2nd trimester pregnancy called amniocentesis, where we look with ultrasound at all times, and a needle is placed through the belly into the uterus, into the amniotic sac, where we take out about 2 or 3 tablespoons of the amniotic fluid, that's the fluid around baby. And these white dots here are skin cells that have sloughed off. And those cells can be grown up in a lab, and we can do various testing. There's also a test done in the 1st trimester that uses either a catheter or a needle to go into the developing placenta. That's what helps to support the pregnancy, to do similar type of testing. And these are specialized tests that we do at Northwestern and are done all around the world. and you can get a chromosome picture. The chromosomes are what package and organize our DNA. And this is a picture of my chromosomes. And that's a really old picture of me. Why am I showing McDonald's? Going back to what our genetic counselors do. So pretty much everybody's been to McDonald's at a number of times in their life, and they understand the menu. And it's not too complicated. But there are plenty of people who have never been to McDonald's or a fast food restaurant in their life, and the menu can be overwhelming. And so can the menu of options for these screens and tests. And so genetic counseling really helps families decide what is the best option for them. And why do we do any of these screens or tests? All these screens and tests are there to give families information to help out with things like planning or reassurance or decision-making. And different families are going to choose different ones. And whatever they decide, we are totally fine with. We also do see patients in genetics preconception or prior to a pregnancy. And most commonly, that is to offer screening to see if one or both members of the couple are carriers for a particular condition. When we say carriers, this is typically autosomal recessive conditions. In an autosomal recessive condition, both parents have to be a carrier for a mutation or change in a gene. And if they both pass it on, then there's a 1 out of 4 chance for the child to have whatever condition we're talking about. We have 20,000 genes. We have 2 copies of them because you get one from your mom and one from your dad. And a carrier means one of the copies works fine, the other one doesn't work fine. And the one that, in a person like this, they don't have any effect because this one kind of takes over. But if this person who's a carrier gets together with somebody else who's a carrier, and if they both pass on the gene that doesn't work, then the child's going to develop cystic fibrosis, sickle cell disease, familial dysautonomia, northern epilepsy. There's a huge list of them. And so we can do testing to help families prepare for an upcoming pregnancy. This is the optimal time to do carrier screening. People do it during pregnancy, but you can also do this prior to pregnancy. And that could change how they decide how to get pregnant. Do they do testing when they're pregnant? Do they decide to just test the baby after he or she is born? Or they could, depending on the condition, if they're both carriers, they could choose to do something called pre-implantation genetic testing, where through what's called in vitro fertilization, a sperm and an egg get together in a lab and grow the fertilized egg up into a larger multi-cell stage, take out one of these cells and test it to see if that's going to have the particular medical problem that you're concerned about. And again, it's for the same reasons: planning, reassurance, decision-making, information. We also do cancer genetics. Cancer genetics is more related to, at least for me, the gynecology part, because if there's a family with multiple people with breast cancer, multiple people with ovarian cancer, or colon cancer, or uterine cancer, a whole bunch in different combinations, and especially if somebody's at a younger age, for example, under the age of 50, maybe there's multiple people with those cancers in some sort of pattern, then there might be a mutation or change in a gene going generation to generation, making somebody have a higher chance to develop cancer. Doesn't mean they're going to develop cancer, it just means a much higher chance. And then with that same knowledge, the information, they could do different screens, whether they're looking out for cancers much earlier in life than what is typical, or a part of the body that we don't normally examine. Again, a way to gain information to improve somebody's health. Most of the time, cancers happen sporadically or completely by chance. Some of the time, it's a combination of genes and environment working together. And it's only about 5 to 10% of the time where it's hereditary due to a mutation or change in a gene going generation to generation. And benefits: it may provide explanation for the history of cancer in a family if they choose to do testing. It may provide information for other family members, medical management decisions, like I was saying. That's the idea. And the genetic counseling around this is crucial to make sure it makes sense for people when they're wanting that information. All right, I should have been timing how long we've been talking, so hopefully I'm not going to go over. So when we are talking with families, we want to make sure that we have a good understanding of potential medical problems going on in the family. So we ask a lot about family history. So this is a thing where I will say it is very important to know about the medical history of members in your family, members of your family, because if there are certain patterns of medical problems in various family members, that could mean that there's a higher chance to develop certain medical problems like diabetes, high blood pressure, cancer, birth defect, a whole bunch of things. Most common medical problems like diabetes, high blood pressure, heart disease is that combination of genes and environment working together, that multifactorial or familial. But certain ones can be more generation to generation. So we ask about family history and we draw it out with what's called a pedigree. So as we draw this out, we have symbols. And so if we're identifying somebody who is male, it's a square. If somebody is female, it's a circle. So squares are boys, circles are girls. And then we connect different people using different lines. So here is a couple and they have, well, they've had 4 pregnancies. They have 3 kids. So you make this relationship line, this horizontal line connecting them. And then for their children, you make this vertical line going downward. That's the line of descent to their descendants. And if it's just one, you would put the square circle underneath. But if they're multiple kids, you then do this horizontal line that's called the sibship line. And then you put these vertical lines underneath that to indicate the individual line. So here there's a boy, a girl, and a boy. And then this small triangle indicates a miscarriage or an early pregnancy loss. So mom, dad, son, daughter, son, and the pregnancy they lost. I already showed this if there was just one kid. If somebody has twins, then you draw one line down and then you have them spur out like this for different types of twins, whether it's 2 boys or 2 girls or a boy and a girl. If somebody doesn't have kids, you just kind of draw the line short. There are different ways to draw it out for adoption. In lots of different ways. And usually if there's a medical problem, we will write it underneath. If that person has a medical problem, we will write that underneath their square or circle. We'll also write their age below the square or circle. And basically we'll draw something like this. And the idea is to look for patterns. If there's a certain medical problem that is common or repeating itself in a family, we might color in those squares or circles to indicate that. And we'll often have a legend saying what the colored in square circle means. I did put that on here. This is a family with a medical problem called X-linked SCID or severe combined immunodeficiency, where this, I saw her in a pregnancy and her son had it. She was pregnant again and wanted to know what are the chances for this pregnancy to be affected with it. We draw pregnancies in a diamond with a P in the center. And then her brother also had it. So this is one of my favorite cases. And then, okay, here's where I put the legend. Here's where these 2 were planning pregnancy in the future. He has a particular medical problem called pseudoxanthoma elasticum, and he had a sister that had something called metaleukodystrophy. Both of their parents happened to be first cousins, interestingly. And if that happens, you draw this double line. So it was a complicated situation. So let's give a couple minutes for you to try one. Hopefully they're not going to go over time. So and I put this here just as a kind of idea again, how to draw these out. So hopefully you have pen and paper with you or just something to scribble on or draw it in your phone, whatever's easiest. So we have a family where there are 3 siblings. The oldest is a daughter. She's 45. Remember, you put the age underneath the square circle. The middle child is a son who's 43. The youngest child is a daughter who's 39. The oldest daughter has a son who's 18 and a daughter who's 15. The middle child has cystic fibrosis. You want to put that medical problem below the square circle and has no children. And the youngest has a daughter who's 10, a son who's 8, and twin girls who are 4. Cystic fibrosis is a condition where both of their parents have to be carriers. And the mom is 72 and has 1 sister. And the dad passed away at age 73, and he had a sister and a brother. So let's take about 3 minutes, and we'll have you draw this out, and then we'll see the answer I came up with. All right, let's see how you did. So to review, there are 3 siblings, the oldest 45, so it's a circle there, and then the middle is a son, 43, has cystic fibrosis, abbreviated as CF, and I colored that square in. And then the youngest sister, 39. They have that sibship line that goes across, and they all came down from that. She has 2 kids. I guess I didn't include these kids' fathers just because it wasn't a part of what I said, but you could draw them in. And there's a son at 18, daughter at 15, no kids for the middle child, and then she has a 10-year-old daughter, 8-year-old son, and twin girls who are 4. So the line goes to there, and then it comes off like kind of on those double cherry stems. Like I said, both parents are CF carriers, so I half color in the square in the circle. She's 72, has 1 sister. He's 73, passed away. I didn't mention what you draw for passing away. If somebody dies, then you draw a slash through, and then has a sister and a brother. And my shortcut is D period died at 73. So this is an example. There are some way complicated ones like I showed. All right, well, since you know how to look at a pedigree, we get the song queued up. There's a funny song that's from the either 40s or 30s, so we'll show it on the end. That's been performed by many people, so I'm going to sing along with the Willie Nelson version. It's a little bit low for my voice, but it will make sense now that you know how to look at a pedigree. Now, many years ago, when I was 23, I was married to a widow who was pretty as can be. This widow had a grown-up daughter, had hair of red. My father fell in love with her, and soon the 2 were wed. This made my dad my son-in-law and changed my very life. Now my daughter was my mother, 'cause she was my father's wife. To complicate the matter, even though it brought me joy, I soon became the father of a bouncing baby boy. My little baby then became a brother-in-law to dad, and so became my uncle, though it made me very sad. Because if he becomes my uncle, then that also made him the brother of the widow's grown-up daughter, who of course was my stepmother. Following that okay? It's a little complicated. All right, I'm going to sing the chorus once, but then the next 2. I know you're on Zoom, but sing along with me the next couple times you do the chorus. I'm my own grandpa. I'm my own grandpa. It sounds funny, I know, but it really is so. I'm my own grandpa. Father's wife then had a son who kept him on the run, and he became my grandchild, for he was my daughter's son. My wife is now my mother's mother, and it makes me blue, because although she's my wife, she's my grandmother too. Everybody, I'm my own grandpa. I'm my own grandpa. It sounds funny, I know, but it really is so. I'm my own grandpa. Next time, louder. If my wife is my grandmother, then I'm her grandchild. And every time I think of it, it nearly drives me wild. 'Cause now I have become the strangest case you ever saw. As husband of my grandmother, I am my own grandpa. Everybody, I'm my own grandpa. I'm my own grandpa. It sounds funny, I know, but it really is so. I'm my own grandpa. Thank you very much for being here this morning. Sorry I couldn't be here, but if you have questions, please feel free to email me. I'll be happy to answer any of them, and enjoy the rest of your morning. Have a good weekend. Thank you so much.